Okay, so solving rational equations. First of all, equations involving rational expressions are called rational equations. So instead of having just an expression like x squared plus 2, we make it, or better yet, make it irrational over x. Instead of just leaving it as that, we would make it a rational equation simply by making it equal to something. In this case, maybe 0 or 4 or whatever the case may be. So now we have rational equations. We're going to solve them. We can solve them in several ways. One way we can solve them is this. So to solve a rational equation, we can put it in the form of a polynomial divided by another polynomial equals to 0 or whatever the number is that we have it equal to. And we can solve that equation, cross multiply, whatever. But generally what you're going to find is whatever makes the numerator 0 there will be your solutions to it. So we could put it in that form. However, we don't have to always put it in that form. Ultimately, what you want to do is to solve it. You can look for the LCD. You've never heard that before, but it means least common denominator. So for the most part, I'm going to look at it that way. There may come times, though, it's useful to look at it this way. So if you need this as a note, I'll go copy it down. I'm about to delete the screen. So let's look at this equation. It says solve the equation for the variable x. Now looking at this equation, before we begin, we should always begin by establishing what x cannot be by. So what x cannot, we have to decide what x can equal to. The reason why is sometimes you're going to get to solving these equations. If we can get solutions, and these solutions would not give me a true statement because in the beginning it would have made the problem undefined. For example, if I solved this equation, I found x had to be, say, 0, I know that 0 really couldn't work because if I plug in 0 in the original problem, it'd be undefined. So we figure out what x cannot be so we know what the extraneous solutions are. That's a new word, extraneous solutions. Basically, definition of extraneous solutions: solutions to an equation that doesn't work in the original equation. So solutions to an equation that doesn't work when plugged into the original equation. So again, extraneous solutions are solutions to an equation that doesn't work when plugged into the original equation. Meaning if I plug it into the original equation, I get something that's false, that is not true, or it doesn't equal to the number they said it should equal to, and so forth. So anyway, we're kind of looking out for those, and you will get those in these kind of problems. Whenever you have an equation and you have to multiply that equation by a variable, you have a chance of creating extraneous solutions. So that could definitely happen here, because we got to do that sort of stuff. So with that being said, starting with this problem, we actually want to solve it. So in order to solve it, one way I would tell students is, if this is, a lot of students are intimidated by fractions. Whenever they see fractions, it just freaks them out. So I would generally tell students, if you really don't like fractions, this is how we can get over it. Make everything a fraction. So make x a fraction, make 3x is already a fraction, and make 4 a fraction. Actually should be 4 over 1. So you actually make all those things fractions. After you've done that, you want to look for the LCD between all these denominators. Basically, it's the denominator that all of these denominators can all equally go into. So when you think about that, it's basically, one way to think about it is basically all the ones that are different down there. Like if I have an x and I have a 1 and so forth, all those numbers are different. So that's one way you can think about what the LCD is. But you basically want the smallest number that all can go into. So when I rewrite this as 1x, that's my LCD. All those 1x can go into 1, and 1x can go into x, and so forth. So anyway, we wind up having x over 1 plus 3 over x equals a 4 over 1. And I got to distribute this 1x into each one of those so that I don't have fractions anymore. The whole purpose of doing this is so we cancel out this fraction, and it's no longer going to be a fraction. And all the other fractions won't be fractions anymore either. So when I distribute this in, a lot of students see this and they still freak out. Like, well, do I take the 1x, I should distribute to the numerator, should I distribute to the denominator? Do I give it to both of those? I mean, exactly how does it go? So because of that, I generally tell them, well, let's make 1x a fraction. If you make 1x a fraction, it'd be 1x over 1. So then, because we had a lesson on multiplying fractions, we already know now that, well, 1x, when I distribute into it, it's going to be 1x over 1 times x over 1. And it multiplies numerator to numerator, denominator to denominator. So I know it's going to be 1x times the x, and the 1 on the bottom doesn't change. So I distributed each one of those. I want to have x in the numerator for each one of those. So that makes it 1x squared all over 1 plus 3x all over x plus 4x equals to 4x over 1. So equals 4x over 1. So if that's the case, I look for what can reduce. Everything should reduce at this point. 1x squared over 1, we don't have to keep calling it that. We can call it x squared now. 3x over x, well, we should recognize that these cancel to just be 1. So it's 3 times 1 over 1, which is just 3. Equals to 4x over 1 is just 4x. So now it's a regular quadratic equation, which we've been working on for a while now. So now it's something we actually solve. We can actually just get this out equal to 0, factor and so forth to try to solve it. So you can keep going straight downward. I'm going to rewrite mine up here though, because I'm out of space. So at this point, because it's a quadratic equation, I can solve it by getting one side to be 0 by subtracting 4x. So now the equation says x squared subtract 4x plus 3 equals 0. So my goal is to try to factor this, if I can. If you don't want to try to factor it, we can use quadratic formula or we can graph it to find the zeros. But truthfully, that's factorable. If you look at that, we should recognize that factors to be, they both have like signs and they both are negative, and multiplies to be 3 and add to be 4, has to be 3, and 1 equals 0. So if that's the case, to finish this, I would say each factor equal to 0. And you'll get x subtract 3 equals 0, x subtract 1 equals 0. So if that's the case, x has to be 3, and x has to be 1. So those are two solutions to that equation. Now we should check those solutions to make sure that none of those are extraneous solutions. But we already decided which solution didn't work. We decided x could not equal to 0. So since I already know x can't be 0, neither of these answers are 0. So they both should work. But just to be sure, I'm going to check it. I'm going to take this equation and replace the variables with 3. And then afterwards, I'm going to replace the variables with 1. So the first one, I'll wind up having 3 plus 3 over 3 equals a 4. Or 3 plus 3 over 3 is 1 equals 4. And that's definitely 4, so it's definitely 4 equals 4. So it works. If I tried the other one, the positive 1, I will get 1 plus 3 over 1 equals a 4. So it gives you 1 plus 3 equals 4. And it's definitely 4 equals 4. So it also works. So both of them do work, and they don't give me a phony statement or a statement that's not true. So those are definitely our solutions to it. So go pause the video, get that as a note, give you a couple more of those to do. Okay, so given this equation, actually try to solve it. So if I actually gave you this equation actually to solve it, what would you think to do? Right now, pause the video and see if you can solve the equation using whatever you understand to do. So go ahead, pause and give it a shot. Well, you might have looked at that and you decided to multiply by the LCD. Or you might have recognized that both of those are fractions. Since both of those are fractions, I can really cross multiply them. So if I have the first side, which is this, equals to the right side, which is this, I can really simply cross multiply here and then cross multiply there. So basically the 2x times x plus 3. And after I cross multiply, it get equals to the product of the other two, 3 times 3x plus 1. And then I solve those little equations. So I will wind up having 2x squared plus 6x. And that's equal to 9x plus 3. So but now this is a quadratic equation. The way we solve those is get one side to be 0. So I would subtract both of these, 9x and so forth. So if I had this equation, 2x squared plus 6x equals a 9x plus 3. I want to get this right side to be 0. So I would just go ahead right now and subtract 9x, and I'll subtract 3 from both sides. And just kill two birds with one stone, take them both away. And now on the right side is just 0. And on the left side, it is 2x squared, subtract 6x and 9x, becomes negative 3x. The 3 is on the end. So what we have now is this, and that's something we can solve either trying to factor it or using quadratic formula. If I look at this, 2 times 3 is going to be a negative 6. I can't think of any numbers that multiply by 6, add by 3. Maybe there are, I just can't think of it off the top of my head. So I'm pretty sure I'm going to have to use quadratic formula for this. Negative b plus or minus b, square root of b squared, subtract 4ac, all over 2a. So if that's the case, I should wind up having now, plug in negative 3 for b, so you get positive 3 plus or minus the square root of 9, subtract 4 times 2 times negative 3, all over 2 times 2. So this is now 3 plus or minus the square root of negative, and the positive is negative 8 times that is positive 24. So 9 and 24 gives you a positive 33 all over 4. So I don't think we can go any further with that. 33 doesn't have any perfect squares in it. So our final answer for this is x equals positive or negative 3, square root of, or this, 3 plus or minus square root of 33 over 4. So that would be the solutions to it. So in some cases, we can either multiply by LCD, which we could have. LCD, in this case, you look for all the ones that are different, and technically this one is different from that one. I can't factor those any further and so forth. So that they would be the LCD. So I will multiply both sides of the equation by both denominators. Let's look at another one though. All right, so given this new example, it says solve this equation, and it looks a lot more complicated. So before we begin anything, we should solve x cannot be. We also should factor anything that's factorable. For example, this may be factorable. So I would rewrite this thing as it would be factored. And if you did, you want to find that this piece factors be x subtract 3 times x subtract 1. So we're looking for the LCD here. Look for all the least common denominator, and it's basically all the denominators are different from each other. So we have x subtract 1, we have x subtract 3, and we have the same thing again. So you have to repeat any of these factors. If you do, it makes the problem a lot harder, and it just messes everything up. So you shouldn't repeat any factors. Any factors that you see there, you only rewrite those once outside that you're going to multiply by. So my LCD is going to be x subtract 1 times x subtract 3. And then I'm going to multiply that by this entire equation. Okay, so if we're going to distribute this through, you may want to actually, everything's already a fraction over here. So if you have any questions about which one of the numbers here, the x that this about both of these should multiply into, I'll just put this over 1. And then it's clear. This multiplies to each of the numerators. So my numerators are now going to wind up being, if I distribute it into all of those, I wind up having 2x times x subtract 1 times x subtract 3 all over x subtract 1 plus x subtract 1 times x subtract 3 all over x subtract 3 equals to 2 times x subtract 1 times x subtract 3 all over x subtract 3 times x subtract 1. So you should recognize a lot of stuff cancels here. So I'm going to rewrite it after I cancel all these things out. So I rewrote all the stuff from the last line so I can write over and cancel things out from it. So if you didn't copy it down, go back and copy all that down and then pause the video and copy it all down. But anyway, I can cancel these, and I can cancel those, and I can cancel both of these. And they cancel be ones. So I got a new polynomial. After all that cancels, all I'm left with is this. And notice we have no fractions left. So we can distribute this into it and have a new quadratic. So if I multiply it all together, I come up with this polynomial. I want one side to be 0, so I'm going to subtract 2. And also I just recognize that I have like terms here, so I can combine those. You want to have 2x squared, subtract 5x, subtract 6. This is factorable. So I'm going to go ahead and factor that and tell you what the solutions is. But you should be able to factor that on your own. Pause it and see if you find the same things I have. So the solution should be 3 and negative 1/2, but 3 doesn't work. You plug into the beginning, you'll find that 3 makes 0 in the denominator and is an extraneous solution. That's all I have. Good luck.